Hey guys, I'm Austin and I'll be showing you how to do 3 different logic gates. These are the components we're going to need: our power supply, 2 longer jumper cables, a handful of the shorter ones, 2 transistors, a 1 kilo ohm resistor, and an LED. For this you can use whatever resistor you want really. It'll just change the brightness of the LED, but I personally chose this one. So if you see on this transistor, there's one side that's flat. For this specific circuit that we're making, you want that to face you. So make sure that the flat side is always facing you for both of these. So let's place them on here, like so. Let's space them out a little bit so it's easier for you guys to see. Our 1 kilo ohm resistor, we want it on the collector side, and if you can see, there's 3 legs here. The first leg is the collector, the middle's the base, and the third leg's the emitter. So we want our resistor on the first collector to the power, which is the red side, and something like that. Okay, so we want to put our LED on here as well. Remember, the short leg is always your ground, so you want the longer leg to the emitter on the second transistor. Okay, and we're gonna ground it. So we're gonna take a jumper cable to the ground and to the blue side, like so. Now you guys can put the LED directly on the ground and then put a jumper cable to the emitter side. I just personally do it this way, I think it's easier. Okay, so our first jumper cable we want on the emitter, so the third leg on your first transistor, to the first leg collector on the second transistor, so something like that. Okay, so then we're gonna, for this one, we're gonna have 2 switches. So your first switch is gonna go on the collector, the first one, to the base on your first transistor, like so. And the same thing on the second one, collector to the base, like so. Okay, so then we're going to take our 2 longer jumper cables. Our red's going to be our power, our ground's going to be our ground, so you can plug it in. You guys can use whatever you want. I'm personally using my laptop to supply this, but you can use a battery or whatever you need to. So we're going to put our red to our 5 volt and our ground to the ground. You can see that the LED goes on, so that means we did our circuit right. Now we have an AND, so in an AND circuit you need both switches connected for it to work. So if you notice, if we take the second switch out, it immediately goes off, connected. If we take the first switch off, it goes out. So we can further explain this with a drawing. And all this drawing is it's the same thing that we built. So we can see it's our 5 volts, our power supply, to our resistor, to our 2 transistors, and our LED. And you can see right here in red, that's just showing that both our switches are on. We can further explain this with the truth table. So all this is saying is that if there's no current in the first transistor or in the second, then there's no current at all, so the LED will be off. If there's no current in the first one, but there is in the second one, that's still gonna be off, so it's still gonna be 0. So we need them both on for the LED to be on. Okay, so that's our first one. So the next one we want to do is our OR. So we can use the same, let's disconnect our power supply. We can use almost the same setup. We're just going to change the jumper cables a little bit. So you can leave the ground, the LED grounded. You always want it to be grounded. So before our jumper cables, we want the first one to be to the collector on your first transistor, to the second collector transistor. So C to C, so first leg to first leg. So then our second jumper cable is going to be our E, so the third leg, emitter to the emitter on the second transistor. So third leg to third leg, like so. And we're gonna have two switches, and they're gonna be the same place as the first one, guys. So it's gonna be collector to base. So first leg to middle leg, like so. And the same thing on our second transistor. So first leg to middle leg, all right? So it should look something like that. So then now we add our power. So red to red, white to blue, and our LED comes on. Now the difference between the AND and the OR, if you remember that when we disconnected our second switch, the light went off, but if we do it for our OR, it stays on. But if we disconnect both, then it goes off. So in an OR, you only need one switch for current to get to the LED. And we can do the opposite. We take the white out, leave the blue in, it's still gonna stay on. And we can show you our drawing, like so. And we can see in our truth table that if there's no current at both transistors, then there's no current at all. Now, if you notice in AND, it was A times B, but in an OR, it's A plus B, which just basically means that if there's current at one, then there's current to the LED. So we can see that. So if it's 0 at A, there's 1 at B, then there's still 1. But if there's current at A, no current at B, there's still current. So in an OR, it doesn't matter if one's disconnected or not. As long as one's connected, there's gonna be light on. Okay, guys? So then our last one is gonna be our NOT. Now let's disconnect our power. We gotta change it up a little bit. So we wanna remove our jumper cables, remove the LED, and we're just gonna keep one transistor. So we want, same as before, you want your resistor to the collector on the first transistor. And then we're gonna put our LED over here. So we want to ground our LED, so short leg to the blue side, like so. So our first jumper cable is going to be C, so first leg. First leg, and then to the first leg of your power on your LED, like so. Okay, so then on this one, we're gonna ground our emitter, which is your third leg. So third leg to the ground, like so. And then our switch. Switch is gonna be just like before. The first leg to the middle leg, like so. So then if we add power, we have power seat, there's no light, which means that no matter what we do with this circuit, there's no currents getting to this LED. No matter if we, take out the switch, put the switch on, immediately goes out, okay? And we can just further prove that with our drawing. As we can see here, the LED is grounded, but no matter what we do, it's always gonna be 0. So if there's 0 at A, then 1 is going to be 0 no matter what we do. So that's our NOT gate. All right. Thank you, guys.